We're looking at the cumulative distribution function, so a bit like cumulative frequency at GCSE, so everything up to a certain point, still with our continuous random variables. And the reason we look at that is if you have a lot of probabilities to work out, rather than integrating for each question, you can integrate once, and that will give you the cumulative distribution function, and then it's just substituting into that to find each of the probabilities, which will save a lot of time. Notation wise, little f of x, or lowercase f of x, is always the probability density function. Capital F of x is the cumulative distribution function that relates to little f of x. So you find the cumulative distribution function by integrating from whatever the lower limit is up to x, so we get x is in our answer, of the function with a dummy variable. That means we can't use x because we want our final answer to be in terms of x, so we need to substitute in x as one of our limits. So we just use a different letter instead of the x in the function, and we integrate with respect to that letter. Because it's the cumulative distribution function, we know that capital F of the lower limit must equal 0, because everything up to our lower limit has no probability, because that's when our probability starts. So that has 0 probability of 0. And capital F of our upper limit, so everything all the way through up to our upper limit, must give our total probability, which we know always adds up to 1. So our capital F of x always gives you the probability x is less than equal to little x. So if we wanted f of 4, that would be the probability x is less than 4. If we extended that, because if we wanted the probability x lies between b and a, all we'd need to do is the probability of, the capital F of b minus the capital F of a. In terms of a graph, you're talking about, I don't know if that's b and that's a. F of b will give you everything up to b, so the probability all the way up to here. F of a will give you all the probability up to here. So by doing f of b minus f of a, you're left with the probability that lies between a and b, which is what we want. So the link between the PDF and the cumulative distribution function is you integrate the PDF to get capital F of x, and then you differentiate the cumulative distribution function to get the little f of x. So integrate to get capital F, differentiate to get lowercase. So in this example, same function as before, same probability density function, 1 over 21x squared for x lying between 1 and 4, and 0 otherwise. So we're going to find the cumulative distribution function and then see how we can find the probability x is less than or equal to 2 and the probability x lies between 3 and 4, so like before, and then we're also going to find the median of x. So solution, first of all, finding the cumulative distribution function for x, we want f of x to equal the integral between our lower limit of 1 and our upper limit of x of f of u du. So all you do is you replace in our function x with u. So we're integrating 1 over 21 u squared, which is where this section comes from. So 1 over 21 u squared du. So integrate that, you get u cubed over 3, and our limits are 1 and x. Substituting in that, we get 1 over 21 times x cubed over 3 minus 1 over 3, which simplifies to 1 over 63 x cubed minus 1. So our capital F of x will always have 3 sections. So the cumulative distribution function has 3 sections. You describe where it's 0, You then have the function and the range that lies between, and then you say that everything above that is 1, sorry. So we've found that this is our cumulative distribution function, 1 over 63 times x cubed minus 1, and we know that that is the function for the range of 1, 2, 4, because we know that from here. So that's where this middle section goes in. So that means that anything, if x is less than 1, then capital F of x must be 0, because we've got no probability below 1 because our range starts at 1. Then capital F of x above 4 must be equal to 1, because we've got all the way through, we know our probabilities must add up to 1, so anything outside that must stay as 1. So that's why we have 3 sections to our cumulative distribution function. You always have a 0, you have the function, then you have a 1. The function, you know the range is, what the range is for. It's 0 below that range, and it's 1 above that range. So now to find the probability x is less than or equal to 2, we don't need to do any integrating, we've done that. All we have to do is substitute 2 in to this. You check that your x value lies between the range, and then you can use the function. So all we're doing is 1 over 63 times 2 cubed minus 1. We're just substituting into that and then finding the answer 1/9, that if you look back at your notes was the same as before. Between 3 and 4 you just do substitute 4 into the function, and then you take away your substituted 3 into function. So it's 1 over 63 times 4 cubed minus 1, and then minus 1 over 63 times 3 cubed minus 1, and you get 37 over 63 like before. To find the median, we just know that all the way up through the data we're finding the point where the probability is 0.5. So we know that f of n must equal 0.5. So all we do is solve when this is equal to 0.5. Solving that, we get m cubed is 32.5, so m is the cube root of 32.5, which is 3.19. At this point, it's always good to check that your answer actually lies in between your range. Otherwise, there might be a slight problem, you might have gone wrong somewhere. So the median is 3.19 to 3 significant figure. That tells us that 3.19 is halfway through the probability distribution.